Welcome to the Core 2 video for our practice test for quadratic functions, equations, and expressions. This is the third video. I'm doing problems 9 through 11. I'll start off with problem number 9. Change the quadratic equation to standard form. Okay? Standard form means no parentheses and no like terms. So to start off with, I have parentheses. I need to get rid of them. I do that by multiplying the binomials. And some people are a little unsure about this, but actually our binomials are just 3x minus 7 and 3x minus 7. This actually means 3x minus 7 times 3x minus 7 plus 8. That's what the squared means. So I do 3x times 3x. 3 times 3 is 9. X times x is x squared. Okay, we're used to having x squared there, but we can multiply the numbers. Negative 7 times 3x is negative 21x. And 3 times negative 7 is negative 21x. And ultimately, I end up with 49 down here. Negative 7 times negative 7 is positive 49. So I can say that y equals 9x squared. And as I usually do, I'm going to add these. Negative 21x minus 21x gives me negative 42x, because I have to combine like terms. Minus 42x plus 49. But the original problem had an additional 8 out there, so I do plus 8. In my final standard form, I cannot have any like terms. Numbers are like terms because they have no x's, so I have to add the 49 and the 8. 9x squared minus 42x plus 57. Okay, that was number 9. Going to number 10. First of all, there's a mistake on your papers. Change the 66 to 45. And work the problem with 45. Okay, it says find the solutions and the vertex for the quadratic equation. Solutions are the x-intercepts, and the vertex is the point where it turns around. There's a relationship between the vertex and the solution. You might look for that. Also, this would be easier if you just had x squared. Think about how you might achieve that. Okay. Pause the video, and when you work the problem, come back and you can check your solution. Okay, now that you've restarted the video, find the solutions. Solutions are things that make, are x's that make y 0. Okay. Also the x-intercept, but the point is y equals 0. So I can say 0 equals negative 3x squared plus 27x minus 45. Okay. Be a lot easier if I had that x squared by itself, but I can easily divide both sides by negative 3. 0 divided by negative 3 is still 0. Negative 3 divided by negative 3 gives me 1. 1 times x squared is just x squared. 27 divided by negative 3 is negative 9. And negative 45 divided by negative 3 is a positive 15. Okay. If I try to factor this, I have to multiply to get 15. I have to add to get 9, negative 9. So I would be multiplying two negatives. My only options are negative 3 and 5, negative 3 and negative 5, which adds up to negative 8. Or negative 1 and negative 15, which adds up to 16, negative 16. So I cannot factor. I have to complete the square. So I do minus 15, minus 15. I'm going to build a square binomial, a perfect square, I have to get my negative 15. I have to get my 15 out of the way. Okay. So I get negative 15 equals x squared minus 9x. Now off to the side, I'm going to take that negative 9 divided by 2, negative 4.5. My negative 4.5, I now square that. And your calculator wants you to put it in parentheses. If I'm going to square negative 4.5, I need to put it in parentheses. If I don't have the parentheses, I'm saying 4.5 squared, make the answer negative. I don't want to do that. When I square negative 4.5, I want to multiply negative 4.5 times negative 4.5. I'm going to get a positive answer. So on my calculator, 4.5 negative, and I square that, I get 20.25. So to have a perfect square binomial, I have to have 20.5 on the right-hand side. So I add 20 point, sorry, I said, can't remember what I said. I need to add 20.25. When I add those, I'm going to take this and move it up here. I get 5.25 equals x minus 4.5 squared. The whole point in adding my 20.25 is so that I can factor that into x minus 4.5 times x minus 4.5. If you want to check it, do the area model, x minus 4.5 times x minus 4.5. You'll see that you get x squared minus 9x plus 20.25. The whole purpose in doing this step here is to make sure that I can factor it that way. Now that I have a perfect square, I can take the square root of both sides. So I know that 5.25, I subtract my 15 or add a negative 15, I get my 5.25. Take the square root of that, 2.29. So I can say 2.29 equals x minus 4.5, or negative 2.29 equals x minus 4.5. Either way, I add 4.5 to both sides. And I get x equals 6.79. Or I'm sorry. I actually have 4.5 now minus 2.9. So I end up with 2.21 equals x. So two possible values of x. And to find the vertex now, I've got my two possible values. So I'm going to quickly draw a little sketch. My graph is going to look like 2.21 and 6.79. Then I'm going to look at my graph. If I look at that equation, it's going to come up and then come back down. and should go through that point. But the point is, my vertex, the point where it turns around, is halfway in between. So to get this value, I take 6.79 plus 2.21 divided by 2. Go back to my calculator. 0.79 plus 2.21 divided by 2, 4.5. 4.5 is where my vertex occurs. My vertex is at x equals 4.5, and I now have to calculate y. So I go back to my original equation. Y equals -3 times 4.5 squared plus 27 times 4.5 minus 45. I do that on my calculator. -3 times 4.5 squared plus 27 times 4.5 minus 45. So I know that my y value is 15.75. So this point here is 4.5 and 15.75. That is my vertex. Okay. Problem number 11. The height h in feet of a projectile launched vertically upward from the top of a 528-foot cliff when time is t equals 0 is given by h of t equals -16t squared plus 128 plus 528. Round your answers to the nearest tenth. First of all, how long will it take for the projectile to strike the ground? Okay, think about that for just a moment. What does strike the ground mean? That gives you a clue. Pause the video, see if you can solve that problem, then come back and check your answer. Okay, now that you have gotten an answer, we can check it really quickly. First of all, hit the ground. That means h of t equals 0. The height equals 0. Okay? So I put that into my equation. A comma. So 0 equals -16t squared plus 128t plus 528. So first of all, make my life easier, I'm going to divide by -16. I divide both sides. 0 divided by -16 is still 0. I have t squared minus 128 divided by 16 gives me 8 minus 8t, and 528 divided by negative 16 gives me negative 3. So I have an equation where it looks like I cannot factor it. Immediately, I have to go to completing the square. I add 33 to both sides, and I'm going to end up with 33 equals t squared minus 8t. I go off to the side, negative 8 divided by 2 is negative 4. Negative 4 squared equals 16. In order to factor this into a perfect square binomial, I need to have positive 16. So I'm going to add 16 to both sides. I get 49 equals t minus 4 squared. So I go to take the square root of both sides. I get 7 equals t minus 4. And we know mathematically negative 7 could also equal t minus 4, but that would be before the rocket is launched. I only want the one after the rocket is launched. So in this case, I only want the positive value. I only consider that. I know t equals 11. Okay? So my answer for A is t equals 11. And now that I've got A for an answer, you also probably could have figured out that I could have factored that. So you might try factoring that. It doesn't matter. You can always do completing the square. Even if you can factor, you can still complete the square. Okay? I'm going to erase that now, get that out of the way, because we have to do B. What is the maximum height? And realizing that, I want to bring that back because we're going to need that. To get the height, the maximum height, I need to look at the graph, and I'm launching it from a building. And we decided this was 11. To get the maximum height, I need the x-coordinate of the vertex, which is halfway between 11 and the other vertex. So I do have to go ahead and say negative 7 equals t minus 4. I add 4 to both sides. I get negative 3 equals t. So this imaginary point here would actually be negative 3. The rocket is never there, but using our math is actually there. Okay? But that helps me find this point in the middle, because I can take 11 plus negative 3, which is 8, divide that by 2, and I get 4. So 4 is my vertex. And actually, we could have ended up with the vertex form in what we did. We had that t minus 4 here. That would give us the vertex form. That would tell us the 4. So I have 4 as my the point where I reach the maximum height. And actually, that's the answer to question C. When does it reach the maximum height? It reaches the maximum height at t equals 4.